The billion-dollar project to reach the Earth's mantle is being compared to the Apollo moon missions. The Japanese-led effort will drill down 6 kilometres beneath the seafloor, passing through the Earth's crust until it reaches the mantle, which has never been breached before. Project's co-leader Damon Teagle says that if successful, the mission could explain the origins and evolution of Earth itself.
We use what is known as a rotary coring bit, which is adapted from the oil industry, but is used for drilling very hard formations. They make a hole that's, if things are going well, about 30 centimetres across, and then would actually grind out a stump of core that's about 6 centimetres wide. So if we have the core, then we can do chemical and physical experiments on the rocks and minerals that we collect.
The mantle is a 3,000 kilometre thick layer of slowly deforming rock between the Earth's crust and its core. Despite forming up to 68% of the Earth's mass, its chemistry and composition remains a mystery. Japanese-funded deep-sea drilling vessel Chikyu is likely to be centre stage. It's already set a world record for the deepest hole in scientific ocean drilling history. Intensive geophysical observations of the sea floor are first needed to help the team decide where to bore. Fresh rock samples should explain how much water, CO2 and carbon is in the mantle and how it evolved over history. Recent discoveries of life forms found deep in the ocean crust have encouraged hopes for similar finds in the mantle itself.
One could imagine that if we had a fault zone that goes very deeply through the ocean crust, where there's cold seawater penetrating deeply into the ocean crust, that perhaps we have life at very great depths in the ocean crust, and possibly, and I say possibly, maybe even into the upper mantle.
The project is still in its infancy, with more funding needed before drilling can go ahead. Even then, the drilling process itself could take years, with current drill tips lasting only 60 hours before needing replacement. Teagle, however, remains hopeful that technological advances will improve the team's chances by the time they're ready to start at the end of the decade.